Our objective is to calculate K. All right, I'm going to do three problems out of TRO. These problems are going to have rice tables in, or ice tables. We may or not have gone over what those are. If just copy them down, I would get one of these for your notes. Right, here's the problem. What's important if I look at this problem? I need my equation, all right, there. That's going to be important. I'm also at equilibrium. I've got these two amounts, these two concentrations, all right? First thing I need to do is write my Q equilibrium. So my Kc is equal to this times this, and they don't have a subscript, not a subscript, but a coefficient. So that's going to be Kc is the concentration of NH3 times the concentration of H2 sulfide. That's my expression, all right? And then what I need to do from there is I need to substitute them in. This, it says in the problem, NH3, its concentration is 2.78 molar, and the concentration of H2S is 0.355 molar. So my Kc would be equal to 0.278 times 0.355. All right. Now, you'll notice these molars things. The molar, these molar things here, they're just going to fall out. So I'm simply just going to multiply these two numbers. Multiply this. These things are just going to fall out of the equation. So I multiplied them and I get Kc is 0.09869, or my Kc is equal to 9.87 times 10 to the negative second. All right. Okay, there's my answer right there. All right. So that's the problem. Let me go back to the book. All right, there's my answer for this problem, 36. And let's go on to a harder problem. Okay, here I go. Here's my next problem, 93. All right, I've got this equation here. It's two different gases forming a more complicated gas. And this one's a little different because they give us an initial pressure, and we're going to need to use Dalton's law of parser pressures and a little bit of stoichiometry to figure it out, all right? And an ice table. All right, I'm going to just pause the video. I'm going to copy down this equation on my paper and then get the initial information on there. Okay, I've got my information. Now I'm going to switch to this. So here's my equation. Here's my initial information. All right, I'm going to set up an ice table. My initial, I've got 5, 2, 2, 2, 4, 2, 1, and none of this. All right. My change, this is going to go down by negative x. Since this is twice as large as that, that's going to be negative 2x. And since this is twice as due, it would be that. All right? Now, therefore, at equilibrium, it's 5, 2, 2 minus 2x, 4, 2, 1 minus x, and just 2x. And the total would be, so that's 5, 2, 2 plus 421 minus x plus 2x equals 748. Okay? So now that's just at this, using this rice table, that's what I get. Now I know, hey, this is the total pressure, all right? Now I can solve this in terms of x. So I'm going to add these two things, and I get 943 minus 3x plus 2x equals 748. So this is 943 minus x equals 748. I'm going to bring this, so minus this and minus x. So we get 943 minus 748 equals x. So that's 52 plus 43 plus 100. 52 plus 43 is 95. So 195, I think. Let's check that on a calculator. I just did that, tried to do that as fast as I could. See if I got it right. 195, good. Now that's x. So that means the partial pressure of this would be 1 minus that. So 421 minus 195 is 126. So the pressure, so x is 195. So this would be I think I got it wrong. 421 minus 195 would be 226. 226. This is going to be double that, so it's 390. And this one is going to be 522 minus 195 minus 195, 132. Okay? Now, I want to calculate my K, or my KP, based upon these pressures. So my KP is going to be equal to the pressure of NO2 squared times the pressure of NO squared times the pressure of O2 without it. Okay? So my KP, I'm going to substitute these into this. So 390 squared over 132 squared times 226 equals KP. Okay? I did it here just so you could see like how this makes that, and then I plug them in. All right. So I'm going to pause it and do the calculator. Okay, so I squared 390, I got that. I multiplied these together. 132 times 132 times 226, and I get this. And then I divide that into this, so 152100 divided by 39378. I get that. All right, so my KP is 0.386. All right, so I just learned something. I went to check the answer, and the answer is it got it wrong because I forgot to convert my answer into the standard unit for pressure, which in this case is atmospheres. So I'm going to do that right now and then resubstitute into my KP expression and then recalculate the answer. So 132 divided by 760 is 0.1737 ATM, and that was for NO. 226, so divided by that is 0.2973 ATM, and that is for O2, and the last one, NO2, is 390 divided by, that's partial pressure is 5.13, okay? 2. All right, now I plug these into this, so this is going to be KP equals oh yeah, I forgot that squared there in the expression. All right, and then I'd solve this, so I'm going to multiply. So I'm going to 0.51332 squared divided by 0.1737 squared divided by 0.2937. And my Kp is equal to 29.3. All right.